Good afternoon, folks, and welcome to our webinar, The Power of Collaboration Among Community Choice Agencies. This is the third in our series of Adobe Foundation sponsored webinars on distributed energy resources in the community choice energy space. Thanks very much for joining us. We're happy to have you on board. Your webinar team today, myself, Woody Hastings, I'm the Energy Program Manager here at the Center for Climate Protection, and Nina Turner, our Energy Program Associate, who will be helping with the questions and answers at the end of the webinar. The Adobe project team includes Michael Clausen, Julie Allingham, and Barry Vesser. They're the ones that have been putting together the webinar series and working on a DER library that I'll mention again in a moment. Our presenters today are Taj Ait-Losin, the Vice President of Technology and Analytics at East Bay Community Energy, and Kristin Terry, Senior Manager of the Climate Division of Blue Strike Environmental. Just a few little housekeeping notes. The webinar is being recorded. If you're just jumping in late, you'll be able to see the full webinar. We keep folks in listen-only mode, and we ask that you enter questions at any time during the webinar, but to just enter those in the control panel. It should be on the right of your screen. And the questions and answers will be in the last 10 or 15 minutes, but feel free to enter a question at any time. There are a couple of handouts also. If you look at your control panel, we've got the presenter bios and PDFs of the slide decks there for you. The recording of the webinar will be shared with you after it's over. So today's webinar, a little bit about today's webinar. The original plan, we were thinking of highlighting some collaboration, several collaborations among community choice agencies on DER programs and projects. And we did find several interesting collaborations underway. There's an NREL funded project that is looking at developing a rate design tool for load serving entities, including community choice agencies, a building efficiency optimization program with MCE on applying integrated DERs to optimize building efficiency. And both of these projects intended to be shared ultimately with all community choice agencies for their use. So some de facto collaboration there, and PCE and LCE working together on that NREL project. Some other aspects of sharing and collaborating include regional programs in Silicon Valley and Peninsula Clean Energy webinars, resource sharing among the California Community Choice Agencies, here at Clean Power Exchange, Clean Energy US, and other forums. So there's quite a number of examples of collaboration, and also collaboration on some large-scale procurements that include storage. However, we decided to focus in on a single aspect of collaboration. So today's webinar, for those that may not be aware, we're going to focus in on one key aspect of collaboration, which is a shared integrated data platform. And so that's what we're going to focus in on as a means of collaboration. And the DER library I mentioned, coming soon, part of this whole Adobe Foundation project is to develop a resource which will be placed at the Clean Power Exchange website, which will be a repository of information and resources on DER. So that will be introduced in the coming weeks, and by the time of the fourth webinar in this series, we should have that to be introduced. I am now going to hand it off to Kristin Terry, so that Chris can take it from here. And Chris, we should see your screen come up soon, and there it is. So I'd like to, and don't forget to take yourself off mute, Chris. And please take it away, folks. Kristin Terry of Blue Strike Environmental.
All right, Woody, so you can see my screen okay?
Yes.
All right, fantastic. And thanks to everyone for joining us for the webinar today. And I also really want to take a moment to thank the Center for Climate Protection and all the folks there that are working so hard to bring these forums for discussion and knowledge sharing to us. They're really meaningful, and they are opportunities for collaboration in and of themselves. And so I just wanted to express some appreciation for that. For those who may not know me, my name is Kristin Terry, and I'm a senior manager actually of EcoShift Consulting, which is the new clean energy and climate division of Blue Strike Environmental. My work really focuses on the nexus between clean energy, climate protection, and economic development. And that happens to be where community choice aggregation lives. I've been engaged with the CCA movement since about 2008. And many of you who are familiar with the East Bay Community Energy Local Development Business Plan Project know that I was the senior project manager for that planning process. All right, so to provide a little context for our discussion today, I wanted to start with just a snapshot of what the landscape is looking like for CCAs. And while it's certainly true that the history of CCA in California has had its share of trials and tribulations that the industry has really met head on and overcome time and time again, I think most of us on the call today would agree that the landscape is increasingly dynamic and complex. And 2019 is going to present some new challenges and I think also some new opportunities. And so this slide was meant to sort of provide a quick overview or highlight of some of those key developments that CCAs are going to be navigating this year. And while, I'm sure that all of us could add some bubbles to the line here, I think this provides a fairly broad overview that's relevant for our discussion today. I'm not going to talk through each of these things in detail, but I did want to touch briefly on a few of them, provide a little bit of extra context for the presentation. But clearly the CCA industry is expanding, growing, and reaching scale rapidly, and that comes with it a lot of sort of opportunities, increased responsibility as well. Along with that, we've seen sort of a very low customer opt-out rate that's been low and stable for quite some time. I think that's a good indicator. It's showing that the CCA industry is established and that trust in the marketplace is on the rise. It'd probably be remiss of me not to mention the fact that the increased frequency of fires and floods and extreme weather is creating many challenges, maybe some opportunities too for CCAs, and that's becoming a really big part of what CCAs have to think about and plan for. There's also some really interesting stuff happening in the CAISO markets. And I know there's been a fair amount of discussion about the somewhat controversial concept of regionalizing the CAISO market. I'm not going to spend any time on that. I think that's sort of early and it's a ways off. What's important, I think, for CCAs to know is that CAISO is working on a number of market developments that can benefit CCAs. That includes things like the multi-use applications rules for energy storage, which is a game changer. And CCAs need to weigh in and be part of that. But there are also changes in the demand response auction mechanism, the DER aggregation space. A lot of these things have relevance for CCAs, and I think it's an important area of opportunity that's emerging. I'm also not going to spend too much time talking about recent CPUC positions, proceedings, decisions, other than to say that many of them have been very, I would say, deleterious to CCAs. And, I will say that particularly the PCIA and the increased cost for CCAs and their customers related to that is a major factor, and so that's part of the discussion for today. Clearly, the bankruptcy, the PG&E's bankruptcy hearing, and the uncertainty surrounding that has a lot of importance for the CCAs, and it's really created some, level of trepidation about moving forward with a number of things, and so we need to be watching that space and weighing in on that as well. And then lastly, I'll say, the CCAs have also really been maturing and evolving in terms of internal capacity and sophistication. And there's been a really strong new focus on the value of data and distributed energy resources in the CCA space. Okay, so then, what are the things that CCAs are and should be doing to remain competitive and continue this phenomenal growth and stability in the industry during this dynamic circumstances that we're facing? There's no doubt that there's many more strategies that we could add to this list, but I wanted to focus on these three, which I think are really central to the discussion. First, perhaps most obvious, is finding ways to reduce costs. Anything and everything that reduced the cost of operating the program and delivering energy and services to CCA customers will help the CCAs maintain their low rates and stabilize those rates, deliver valuable services and programs, and ultimately enhance the financial performance of the CCA itself. And, this goes well beyond getting low prices on energy supplies. It includes things like building internal capacity and infrastructure and resources. It includes reducing expenditures on external consultants and service contracts, and investing in smart, targeted, dispatchable DER deployments, and also things like improving our rate structures and load forecasts and settlement processes using integrated data analytics. And all of this is really about leveraging the ever-increasing scale and maturity of the CCA industry and increasing our operational efficiencies. But another important strategy is identifying and mitigating risks. Overall, the CCAs have done a great job of managing market risk exposure and building strong financial reserves. However, the potential for CCAs to implement risk mitigating contracting mechanisms, utility-grade energy trading risk management systems, and more sophisticated scheduling coordination in ways that protect the CCAs and their communities of customers and stakeholders is substantial. And I think we're going to be seeing CCAs beginning to invest more time and resources in this arena. And lastly, we've seen a lot of energy and focus going into the growth of the CCA service territories. We see this in the rapid growth of the number of active CCAs, as well as the expansion of existing CCAs to include neighboring communities and customers in other areas. Clearly this is an important strategy to grow the overall CCA load and the revenue base, but there are other ways to increase revenues. And we are seeing CCAs beginning to explore opportunities for load growth through other things like building and transportation electrification or demand response, DER aggregation, or the virtual power plant concept. All of this really brings me back to the topic of the day, which is collaboration, because as it turns out, collaboration is a fundamental part of the CCA story from the beginning. And it is one of the most critical and unique tools in the CCA toolkit when it comes to maintaining a strong competitive advantage over the IOUs. Going all the way back to the early days of the movement, we saw that collaboration was part of the story of the formation and launch of all CCAs from the beginning. I believe that all of the CCAs in operation today have benefited from collaboration and knowledge sharing from those who came before them. And CCAs have banded together to fight unfavorable legislation and regulation and advocate effectively for fair treatment and a level playing field. And this continues to evolve in venues like Cal CCA, which has provided a central clearinghouse of information and a forum for collective action. We've also seen a lot of recent collaborations emerging between CCAs on the procurement of resources and services, with a number of notable and innovative examples. You heard Woody touch on a few of these earlier. I'm just going to say, the recent collaboration between Silicon Valley Clean Energy and Monterey Bay Community Power for large-scale solar plus storage was the first of its kind, and it included some really important innovations relating to flexibility and dispatchability of those resources. We also know that there's a growing interest in the potential of CCAs to work collaboratively on the development and implementation of local programs, which will also likely include joint procurement of technology vendors and service providers. And recently, the concept of a regional approach to procurement is getting more traction with the announcement of an exploration of the Super JPA concept, which was announced by Monterey Bay Community Power a few months ago. So what are some of the other opportunities for CCAs to benefit from collaborative action? I'm not sure how many folks on the webinar had thought about this before today, but one area that CCAs have only just begun to delve into is advanced data management. The potential for CCAs to work together to develop a standardized integrated data platform that better serves the needs of these unique programs and allows the CCAs to accelerate the transition to an advanced energy community concept that many of us are excited about is significant. The cost of building such a platform, though, has been out of reach for individual CCAs to date. But by leveraging the combined economy of scale and sharing those costs, this can be overcome. And as many of us know, the value that can be extracted from the data that is readily available to CCAs today is truly immense, and it's largely untapped to date. But we're going to hear more on this topic from Taj momentarily. So let me finish with this last thought. Many of the exciting innovations that relate to DERs and the value they can deliver to CCAs and their customers are currently constrained. And as currently constructed, CCAs are really not in a position to realize the fullest benefits of those advanced DER applications. This has a lot to do with limitations relating to constraints around data access and management, relatively simplistic schedule coordination capabilities, and the fact that CCAs currently schedule and settle almost everything in the day-ahead market. In order to reap the full benefits of DER and local load reduction programs, CCAs need more sophisticated data, trading, risk management, and scheduling capabilities. The problem is that the cost of setting up and staffing a 24/7 control room is just not justifiable for most individual CCAs. But this is another area where collaboration will be the key to success. And I want to wrap up by saying that the work that EBCE is doing on the development of the integrated data platform is building a foundation for this 24/7 control room concept, which will rely completely on data flows and advanced analytics. And so that's a great segue to our next presentation, and I'm really thrilled to hand this off to my colleague, Taj at EBCE, who's the Vice President of EBCE's Technology and Analytics. And I'm going to hand this off to Taj. Give me just a moment.
Great. Thank you very much, Chris. Can everybody hear me okay?
I hear you loud and clear.
Great. So hopefully you can see my screen. Let me just get to my presentation and display the presentation. So thank you again, Chris. Thank you to everybody who's in attendance today for your time. And thank you to the Center for Climate Protection for organizing these webinars and inviting me to speak on our work so far on our integrated data analytics platform. Just to give you a quick background, my name is Taj Aitlausi, and as Chris said, I run technology and analytics for East Bay Community Energy. I've been here about a year. I have a background primarily working for software companies or service providers that provide energy management, energy efficiency, and demand response solutions to electric, water, and gas utilities. Most recently, I was with the Data Raker Group within Oracle's Utility Global Business Unit, working on advanced meter data analytics. So East Bay Community Energy is the community choice aggregator in the County of Alameda. We have about 550,000 customers. We just finished launching our residential customers in November. And so we're pretty much all rolled out except for a subset of our customers that are on special rates. So my presentation today is going to be kind of an overview of a analytics platform that we've been working on over the last year or so. And in the spirit of the collaboration aspect that is behind these webinars, I'm hoping that this presentation will trigger some thoughts and some realizations about what can be done with technologies and the data that is available today. So just to put things in context, the platform that I'm talking about, and in fact, speaking of collaboration, this is a slide that Don Bray at SBC developed that I worked with him on, but we were really trying to put things in context. There's so many solutions and so many components to a data landscape today that it's really important, I think, to first realize exactly what we're talking about. So this slide is pretty busy, but it tries to lay out the whole landscape of customer service solutions that are available out there that CCAs need to interact with. There are obviously billing transactions that CCAs must work with. There's customer relationship management that CCAs must handle. There are several system data transfers between PG&E and ourselves and all the people that we procure and power from and settle with, and obviously with the California Independent System Operator. But what we're going to talk about today is really one component of that solution, which is a data repository or warehouse and a set of analytic tools that are designed to really unlock the value of all of the data that CCAs can avail themselves of. California spent, I think, by my own estimates, upwards of $10 billion converting its metering infrastructure to what is known as AMI. That means that every single customer, pretty much every single customer in California, has a meter that collects information on a very granular basis. And it's either hourly or 15-minute, depending on the meter and the service area. And really the impetus behind collecting information in such a way is to really promote novel, innovative rate designs and rate approaches, and have really better communication between the utility and the customer about what they're consuming, when they're consuming it, and what potentially they can do to respond to price signals. So this is really the data that is the foundation of what we're going to be talking about today, and it's considered in the industry, it's considered big data. So EBC Platform 101. I like to joke that this is kind of like after the fact, realizing, oh, what exactly did we try to do? But so this foundation principle isn't something that we necessarily set out to say this is what we're going to achieve. However, the local development business plan that Chris was mentioning early very much called for immediately an integrated data platform. So we knew that we wanted to build something that could handle the data. But ultimately, the foundational principle was to have a platform that can synthesize all customer data, all usage data, and all transaction data in one common environment, so that we as a CCA could have full visibility into the conditions in our system at any point in time at any aggregation level. And this is not just for us, it's for our customers, it's for our partners that work with us that may want to avail themselves of this information. So the idea is to have full visibility into effectively all the transactions, all the exchanges that are going back and forth between our customers and ourselves. And this can be very much extended, by the way, to not just consumption information, but also information. We do have customers today that supply energy to us, and that information is coming into our platform, but that can be extended to distributed energy resources. So with that foundation, we decided we would bring in a variety of different data sets. First, we obviously need to understand our customers, their status and their characteristics, who they are, what their rate class is, for example, what their zip code is, etc. So in the case of PG&E, this comes through a file called the 4013, which is a weekly file that tells us, all the programs that customers are participating in, etc. We also wanted to incorporate, obviously, usage data. Here we're talking about the usage data that comes from those meters. So in the case of PG&E, we're integrating with what's known as Share My Data, which is a platform that gives us access to that information. We're bringing in transaction data from our third parties that are managing all sorts of billing transactions and purchase and sale transactions. And then we're also bringing in enriching data. In this case, I'm talking about things like weather, tax assessor data, the records that the County of Alameda has about parcels, square footage, number of units, etc. And we're also working with our scheduling coordinator, which is the entity that settles with the California Independent System Operator. We're working with them to pull all the information that they have about transactions as well, and about things, publicly available information about what's going on with the California ISO prices. So all of that goes into this one common platform, and the objective is to do a lot of different things. One obvious thing is doing classic analytics. I'll speak more to this about it in a few slides, but slicing and dicing the data, looking at what happened in the past, looking at what's happening right now, looking at what could be happening in the future. We have a lot of reporting and compliance obligations, so this platform is also designed to meet those. And we do what I'm calling shadow reporting, which is to basically do our own version of all of the reports that our consultants and our third parties are generating for us, just to kind of get a gut check that the numbers are lining up and that there's somebody else there to just double check to make sure that we're not misrepresenting or miscalculating something. We're also doing a lot of load analysis with this platform. Profiling and settlement is one of the key components. We're profiling every single one of our customers, and we use that for settlement purposes. What I mean by profiling is we come up with a model to determine what we think the energy consumption of our customer is going to be based on characteristics like which rate class they're in, and then what day of the week it is, what month of the year it is, what hour of the day it is. We can normalize according to weather, and this enables us to do a short-term forecast as well as a long-term forecast. This platform is also used for rate design. Just to give you an example, PG&E is PG&E is working towards an implementation of new time of use rates. We've used this platform to say, okay, what would the impacts be to EDCE from a revenue perspective if we converted this group of customers from rate A to rate B based on what their historical load usage has been. And then finally, products and services. If we have a better understanding of what's going on with our data and our customers, then we can better understand how to target customers for products or services that are going to be beneficial to them, as well as beneficial to the load shape of EDCE, and therefore beneficial to the CCA and the County of Alameda in general. So that's just the platform in a nutshell. Now, how do we build this, and why do we build it that way? So we built this platform using what are available out there in terms of cloud technologies. So we settled on that somewhat accidentally, but there's several reasons ultimately why it made sense for us to do that. First of all, performance. If you use cloud technologies, you avail yourself of industrial strength performance. You do not need to have a single piece of equipment, but you can have access to very, very large scale computational power. And you have also access to capabilities that are only available to the cloud, that you would just not be able to have even if you had all the money to spend on equipment. So for example, right now with the cloud technology that we have over 86 billion rows of data. They are representing over 3 terabytes in total, and over 100 different tables of data. But all of that data, because we are putting it in the cloud, we can, for example, aggregate the hourly usage or 15-minute usage of 500,000 customers from the bottom all the way to the top in less than 10 seconds. Or we can say, I want to do that aggregation, but I want it to be by zip code and by rate class and by care or care indicator and by whether the customer is NEM or not, etc. We can add all these different dimensions, and that would take less than a minute to run. Every time it's rerunning everything from the bottoms up. That's the kind of power and performance that we can get from these types of technologies. From a cost perspective as well, there's very little overhead required. You don't have to have a team of people dedicated to running the application. There's very low cost of entry and operation. Right now, what I just described costs less than $2,000 a month just to operate. And we currently have 1.5 FTE that is dedicated to not only running the system, but also answering the questions that people want to have answered out of that system. And finally, accessibility and expandability. And I think this is one of the key points of the presentation today, the idea of the presentation today. This is a very scalable platform. It's very much extensible to different CCAs, or it's repeatable and it's scalable, and it's also open. So any third party that we want to share information with, or any third party that comes to us that says, I have this killer application in forecasting or this killer application in settlement, we can have this platform be completely open to them. They can integrate with that platform and have access to the information. Similarly, some of the cities that we work with, the jurisdictions that we work with, want to have access to the information about their customers. What are the greenhouse gas impacts of having switched to CCA? Again, because this platform is open, we can have access to that information be made available. So what does it do? So what I'm going to show you next is a series of dashboards that are effectively interactive ways to integrate, to interrogate the system and have access to the information. So as I mentioned, every single one of our customers, or nearly every single one of our customers, it's close to 95% of our customers is interval metered. And we have that information, so we get either 15-minute data or hourly data for all of our customers. So also get bill information for our customers, obviously, and the bill information typically goes from starts on a particular date and ends on a particular date, and there's an amount of energy that is consumed during that time period. And that's ultimately the information that we use to settle with the California Independent System Operator. So we take all of that information and we jumble it all together through our algorithms, and we ultimately come up with what we consider the best view of the load at any point in time. What you're seeing here is a graph that shows you the month of January and February of 2019, and the top line, the very top line, is effectively the total system load for East Bay Community Energy. So you see weekly variations. You can see the weekends, 2 days that are slightly lower, those are weekends, and then you see weekdays. So that's the top line. That's our best estimate of what the top line is. And this is calculated from the bottoms up. We did not put this in an Excel model. We said, take every single customer and add up what you think their best understanding of usage is for that particular hour. Now you can see all those colors there. So that's basically the combination of the different types of data that we have to come up with what that top line is. Green is the best. Green is, you've got interval data for all of the hours in question, and you also got a bill that anchors before and after that interval data. So you have both pieces of information, you make sure that they agree with each other, and then you add up the load of all the customers for which you have that information. So you notice that green is great in January, but we have less and less green as we move towards February. Why? Because we don't have bills for people whose bill cycle, say, is January 15th to February 15th. So we don't have a bill to anchor the interval data with. That's when red comes in. Red is you have interval data, but you don't have a bill to anchor it. You don't have to wait for the bill. You can use the red data. It's perfectly good data. We've done some analysis. 99.5% of the time, it fully agrees with the bill once the bill comes in. So that's the red data that you can keep adding. But at one point, meters are obviously not metered in the future. So in this case, this report was run a couple of days ago. By February 9th, we don't have any more interval data. So at that point, we have to switch to say, okay, you don't have the green data, you don't have the red data, but I have my profiles. So I can estimate what I think the customer is going to be doing based on what I know about the historical pattern of that customer. And furthermore, I can look at what happened in the past, and I can come up with how far off I was in that estimate in the recent past. And so that's what the purple is. It's basically a load profile that's been calibrated against recent errors. And then finally, after 10 days into the future, we don't do that calibration anymore. We just say, we're just going to use a load profile because recent behavior is no longer that relevant for prediction. So I spent a lot of time on this slide, but that's really to try and give you the idea of the logic behind the whole entire platform. It's giving you access to every single customer's best understanding of what their load is, dependent on every specific customer's load data that's available to you. And then you can do it in the past, obviously January 1st, and you can do it in the future, February 28th. And if you look at the pattern of the top line, you'll see that there's not that much of a jarring discrepancy between past data and future data. And we're working right now to provide this information specifically to our scheduling coordinator, and they're using that information into their load forecasting algorithms. Once you have that data, you can look at it in many different ways. So this is the same graph that we just saw, but looking at it from a daily perspective and looking at it in slicing it and dicing in a different way. So here we're seeing the rate, the distribution by rate class. We're looking at the distribution by jurisdiction, and we can see, for example, in the bar chart, we can see the contribution to load of each rate class. So you'll notice how in November, December, and January, that really ugly green is showing up. That's the residential customers that we recently launched. So they're not making up over a third of the total load that we're seeing. So that's another way of slicing and dicing the data. This chart is very useful for program design, at least I think. It's instead of looking at it in a time series basis, it's looking at this from a load shape basis. So every time we're looking at a 24-hour period, you start on the top left, looking at it just overall, to the bottom right, which is looking at it month by month by month. And you can also look at it, for example, the bottom left by NEM customers, net energy metering customers versus not net energy metering customers. You can look at it by jurisdiction, which is what that center graph is. You can look at it by average season, summer versus winter. And you can even look at it from care, THERA, medical baseline customers versus not. Again, these are not just static reports. These are reports that are self-service, that our team can just go in and interrogate and hone in on a particular shape that they're interested in and export the data if they're interested in using it further. The other type of reporting we're doing, this is the type of shadow reporting I was talking about. So this is basically taking a lot of the transactions we're getting from PG&E and from our third parties, and basically coming up with what we think the data is saying. This is what our finance folks are using to compare to the data that we ultimately report in our audits, as well as the data that our banking transactions are showing coming in and out. So that's an example of shadow reporting. This other type of shadow reporting that we've done, this is the billing transactions, where we're basically looking at every single billing transaction between us and PG&E and figuring out where they fall out. So this particular snapshot showed that at that point in time, we were on our 881,000th transaction, of which 859,000 were perfectly clear, and it took about 7 days between the time the cycle closed and the transaction to be completed. But then you have some transactions that are either in orange or red or dark red, which are exception transactions that are either pending completion or there's a piece of information that's missing that's preventing us from completing those transactions. Again, this is a shadow report. This is not, we're doing this just to make sure that we have a good visibility into the transactions going on with our system. And then finally, the jurisdiction report. This is probably the most used report that we have here. This is just to give you the sense of self-service that people can do. This is basically updated every day. It shows you what's the situation with how many customers we have enrolled, at what level, what jurisdiction level, what the KWH is associated with those customers in 2019, what we're predicting it to be, and then same thing for opt-out, and then same thing for to be enrolled. And so you quickly get a sense of what jurisdictions maybe are seeing higher opt-out rates for whatever reason, as well as the difference between an opt-out by customer versus an opt-out by KWH. So this platform is already paying dividends in the sense that it has provided us with value in two very specific areas. As I mentioned, the load and revenue forecasting and settlement was one of the key things that we did. So as I mentioned, we provide to a scheduling coordinator the last 90 days and the next 10 days of our forecast. And so they use that information to basically determine what to plug into their algorithms that then decide which types of transactions they're going to be continuing through or making modifications to. One of the interesting things here, and this is something that the folks, our friends at GridX, identified first for Monterey Bay. It's the difference between doing the settlement with the ISO with using PG&E load profiles versus your own built-in load profiles. That's what that chart is showing you. In red is the settlement according to PG&E load profiles, which is currently what we're doing. And in blue is the settlement according to our dynamic load profiles, which is what we're moving towards. And you'll notice that this is in September. You'll notice that the red lines are peakier. And that makes sense because we are in the county of Alameda. We're not in the Central Valley. While it gets hot here, it doesn't get nearly as hot as it does in the Central Valley. So the load profiles that are system-wide for PG&E, even though they are weather zone specific, are not necessarily the best profiles to use because they overshoot the load during those peak summer hours. The other thing that this enables us to do is to have visibility into future loads and revenues. So everybody that's been involved in the CCAs know that the PCIA is one of these huge unknowns. We've been able to use this platform to help answer questions from our executives and the board to say, okay, if the PCIA is X and PG&E does Y with its rates, what will the revenues look like in 2019? So we were able to use this platform to do that type of analysis. Similarly, on the customer service and program design side of things, we've performed some customer segmentation. This chart here is just this preliminary work that we've done, but it's basically looking at the correlation between this hourly usage and temperature. And we're trying to identify customers that either are strongly positively correlated to temperature or are uncorrelated. So strongly correlated are the pinkish ones, uncorrelated, the red ones, or have an inverse correlation to temperature, which means they actually don't seem to be increasing their usage when it's hot. They actually maybe decrease their usage. And this is the stepping stone towards understanding who has either air conditioning or electric heat. And so you'll see those are the different load shapes of those customers. As I mentioned, PG&E's TOU transition is something that we need to understand. So we've done some analysis to understand what this is going to do to our rates. We implemented a pilot demand response program, which we used our platform to do the settlement on. And finally, we have customers coming to us that want to have access to their data. And because we have this platform and it's somewhat self-service, they can ask us for the data. We can pull it out of our platform and provide that information directly to them. So why did we develop this and why does it matter? I think this is another one of these slides where it's like after the fact, maybe, but I've worked in this business long enough to know that I think unfettered access to data is really necessary and fundamental to innovation. If you don't have access to all this data, you can't really come up with the rates that you want to come up with. You can't really provide the customer the signals you want to provide them. So really, fundamentally, you want to have access to your data. You have to understand how the behavior of your customer is driving their usage and what impact this has on EBCE for us, the County of Alameda, and the state of California in general. And you can only do that through data. You have to develop, and you can develop the right product for the right customer at the right place and at the right time. And finally, you can create an environment where customers, local government, third-party service providers all can have access and visibility into the energy landscape. You do not need to say, oh, sorry, all this interval data is residing in a separated file that is really, really hard for me to pull. And in fact, it got deleted because the server got cleaned out. It's all in a living system. And if a third-party provider comes to you with a great settlement solution, or a great forecasting solution, or a great customer segmentation solution, or a great customer targeting solution, or a great collaboration idea, you can say, here's the data. We know our customers. We're not operating in the dark. So the next steps for us, and then I think we're going to have time for questions. It's that load really is just one side of this equation. It's the fundamental stepping stone. This is where we have to start. But the platform can and will extend itself to the incorporations of distributed energy resources. So as I mentioned, we already are getting KWH received from the customer in our data platform, but there's nothing about what we've designed or built or the tools that we're using that is limited at all to just the load side of the equation. So we definitely have big ideas for what to do next. Also, this is just one component. Going back to that very first slide that I showed you, this is not meant to be the end-all, be-all of everything that EBC does with data, but it's a fundamental component in the sense that it allows integration with other systems, other services, other providers, and it will help us be innovative. And finally, collaboration and other joint activities with other CCAs are definitely something that we're pursuing. We've already socialized what we've done so far with this platform. Hopefully today's presentation is giving people ideas of what's possible out there. But we definitely are looking to see how this can be extended and the lessons can be shared and the capabilities even can possibly be shared with other CCAs. So that ultimately, we're moving away from just using Excel as the way we analyze and understand our customers. So that's it for me. I think my next step is to pass it on to Woody. So I will try and do that.
Taj, while you're doing that, I want to thank you for that. That was really exciting. I think probably for everyone on the call to see what EBC is doing with the platform and where it's going. And I want to encourage people to submit questions using the chat box. I see there are a couple there. I'm going to maybe kick off the question portion here by asking you, Taj, to sort of dig a little deeper on the collaboration concepts. That's the focus of the webinar today. I'm hoping you could maybe sketch or provide a sketch of how that collaborative approach might work and sort of what benefits you see in that. And then also, is this something that other CCAs who are interested in could reach out to you in terms of being part of that collaboration?
Yes, absolutely. So please reach out to me. I think we've already had conversations with CCAs, some of the CCAs here in Northern California about what we're doing, where we're at, and what the possibilities are. I think in terms of collaboration, I think what's important about collaboration is, first of all, to understand that there are tools and technologies available today that are making this entry into this field of big data and analytics easier than it's ever been. So with that said, I understand I have a background in software and I've never been a developer, but I have enough of a technical background that it was probably easier for me to come in and make that realization and then work to develop that. But other CCAs may not, want to pursue that, but there is the opportunity for CCAs to share into a platform of this nature because it is extensible, it can be repeated, and also to share resources. A CCA may not have the need for, let's say, a full-time data scientist, but there's potentially the opportunity to not only share the infrastructure, but share the services and to avail ourselves of maybe a shared pool of resources. And then finally, lessons learned, right? We've learned from what Monterey did in the settlement and what GridX did on the settlement side. We're all working together. We've learned from the work that past CCAs have done about the pitfalls and the things we need to do about getting access to interval data. All of these things are things that we've learned from other CCAs. And I think the more we see what each other can do, and the more we can share with each other the capabilities, the more we can get to that point where we're really truly extracting all of the value out of all this data that's been collected on our behalf and that California spent a lot of money to collect.
Fantastic. Okay, I'm moving to some audience questions now, and we've got one here related to that last comment you made, Taj, which is, what are the barriers that you see to implementing a CCA-wide analytics platform?
I mean, there is. You mean like across multiple CCAs? There's always going to be the barrier. I think there's always going to be the barrier that there's different ecosystems of vendors, different sources of data. So there's going to always be the one-offs that you're going to need to do from one CCA to another CCA. Then there are also barriers, I would say, that are more structural within the current utility makeup. Share my data. I mentioned this before. It's not designed to do what we're doing with it. It's been configured to enable us to access interval data that way, but it's not the ideal way to do it. There are structural barriers, I think, right now that are existing with the way we've decided or agreed to or accepted the status quo of how data gets exchanged between incumbent utilities and CCAs. If we work together and we come to the table with a unified front and unified ask that's saying, let's revisit some of these givens and let's work on improving that, that's how we can probably break that barrier down.
Very good. I would add one piece to that, which is that there are differences between the IOUs. The 3 different IOUs have differences in their data systems, differences in the data sets themselves, and that creates some challenges. I wouldn't necessarily think of them as insurmountable barriers, but they are certainly challenges that would have to be considered in a more broad data platform design process. Another question from an audience for you, Taj, is how do you handle data security, encryption, etc.? What safeguards are in place?
Yeah, that's a very important question, and one that we've been fielding a lot. So the very first thing we do is we just don't put unnecessary information that we don't need to use. So we're working towards removing pretty much every single personal identifier from our data systems because we really don't need to have that, and we can just operate with just a single identifier called a service agreement. But even then, the technologies that we use are industrial strength technologies when it comes to security. So in the case of the platform we use, the data is encrypted at rest and the data is encrypted in transit. And all of this data that's in that platform that's encrypted at rest and encrypted in transit arrives to us with less security than that. So the source of the data that comes to us has less security applied to the data than we actually subsequently apply to it. So that's how we've addressed that. And so the platforms that we use are platforms that are used by financial institutions, are platforms that are used by extremely high risk organizations were there to be a breach. This may not be something that everybody in the audience knows, but CCAs do not collect driver's license numbers, passport numbers, social security numbers, the credit scores, any of that information. There is publicly identifiable information in the form of name and address, but we do not have that next level of information, such as social security number and all that. But that said, we're working to completely remove even the names and addresses out of our system because we really don't need to have it to do everything that I just described.
Really good. And we've got a couple questions related to a common issue here, which is the issue surrounding the lag time between when the energy consumption happens and when the CCA can have access to that data. I know that this lag time tends to be a 24 to 48 hour window before the CCA can have the interval data from the meters in its territory. And that presents some challenges for particularly any kind of real-time load shedding, load shaping kind of DER applications. And so can you speak a little bit about the lag time issue and whether you see that as problematic for what you're working on?
Yeah, that's a very, very good question. So just quickly to describe the lag time. So PG&E collects its information through what's known as a head-end system. And that head-end system makes the information available typically 24 hours to 48 hours after the meter was read. That is a fact. That is the way all head-end systems work, whether it's Landis+Gyr, Silver Springs, any of those head-end systems. They are not real-time systems. AMI systems are not designed to provide direct access to a meter. The meter posts its data or is read, the data is condensed, coalesced, it's packaged, and then 24 to 48 hours later, it's available. On top of that, we add, it probably takes another 1 to 2 days. So we're about 4 days behind. But no matter what, you would never, even if you were PG&E, using AMI, you are never actually directly talking to the meter, unless you've configured meters or systems in very specific ways. So that's absolutely doable, but then it's really done typically on a case-by-case basis or for a subset of customers. So in the case where we're talking about those types of products that require real-time access and real-time data, then really the answer is to look at technologies that enable that, either through maybe the head-end system or through other solution providers that are available out there. But I would venture to say that we do not need immediate real-time access to 500,000 customers in the County Valley. I think we're perfectly okay with the lag that we're seeing through the head-end system and what we are getting, because we already can do very important things like provide our scheduling coordinator with information literally for the next 10 days.
I just want to springboard off of one thing that Taj said there, which was when you get to the point where the real-time data streams are important, there are solutions to that issue, technology solutions primarily, and they are in some cases very low cost and easy to administer. And this involves things like HON metering devices or non-invasive load monitoring devices that the CCA can deploy along with DER programs. You take the energy storage benefit incentive that we provide. That means you also have to install a HON device. And that HON device is configured to send a real-time data stream back to the CCA so you have real-time visibility into that load. This could be very effective and powerful for large C&I customers or geographically separated customers to give the CCA real insights into what's happening to its load under certain circumstances, changes in the weather, for example. And that becomes very valuable for things like real-time DER programming. And so with that, I'm going to take one more audience question here, which is sort of a very specific one. Does the tool have a feature to calculate the hourly gross margin of electricity sales, historic and future?
So that's a question that my management asked me very early on. And so we don't have like modules or anything like that. We have a platform where all the data lives, and then we have processes that basically do things to that data so that it's then available to report on. So when it comes to gross margin calculations, we work with our procurement folks. We have the load data, past, present, and future. We have it by rate class. We have price information, historical price information, and that information is available on an hourly basis. So boom, with those two pieces of information, we can actually do that calculation very quickly. It's one of those calculations that I listed in the very beginning of my slides. It's one that takes less than a minute for every single customer. I can calculate for every single customer what I think is going on in terms of how much they're using, how much they're paying us for that hour, and how much we have to buy for that particular hour.
All right, with that, I want to thank Taj and all of the attendees today. And again, one more thanks to the Center for Climate Protection and our sponsors, the Adobe Foundation. And I want to hand this back to Woody to do the wrap-up.
Right. Thanks very much, Chris and Taj. Fantastic presentations. You two made it really easy for Nina and me. We didn't have all that much to do. So thanks for fielding all those questions, Chris. You know, I just want to say, you know, this resource that Taj presented, you know, there's 19 operational community choice agencies. They each have their own, you know, their own color, their own staffs, their own skill sets among the staff. And I think this is just a really fantastic example where, you know, you've got Taj coming in from a big data background and bringing something that's really really compelling and really obviously powerfully useful, and that's something that can be shared among all community choice agencies, and all of them are collaborating and sharing information. So yeah, I mean, I think it's just this real synergistic thing that I'm seeing here with all the agencies collaborating, and it's a a beautiful thing to see. So thanks very much for sharing all of that. Just a couple of upcoming things. Tomorrow, is it tomorrow or no? I'm sorry, it's Friday. Friday, not tomorrow at 10 a.m. Friday, the Lean Energy US market call. So ignore that tomorrow on your screen. It's Friday, the 15th at 10 a.m. Our next Adobe DER webinar, the fourth in this series, will be sometime in April. We don't have a date set yet, but we will be sure that you hear about that. Our next Clean Power Exchange webinar, though, will take place on workplace EV charging on March 13th at 11 a.m. And then we just set the date for the next Business of Local Energy Symposium that I'm sure many of those folks on the call today have attended in the past. It's June 20th, 21st at Hotel Irvine in Irvine, California. And for those who have not attended, you know, I'm a little bit biased, but I think it's a fantastic event and you should all get your ticket. I think that may be everything. Right, that's a wrap. So thanks again, all. Thank you, Chris and Taj, and the Adobe team. And thank you all for attending, and we'll see you next time.
Good job, you guys.
Thank you, Michael.